Hello students, yesterday we have discussed about average and we have seen the concept basic way, and what was average is, the first characteristic of average is it will always remain between extremes. It will always remain between extremes, and then the basic formula for calculating average is sum of observations by number of observations. This we all have seen in the previous class. Now I see some of you are already getting excited when I said since we have seen in previous class, but following in the same template that we have seen for all the topics, is this the most efficient way? Is this the most efficient? I would have to say no. If you are already habituated to my style of teaching, then this is no. So let's see a beautiful way of solving average problems. Normally, let's take a set of numbers. These look good as any other number for calculating the average. If you go by our basic method, like all people do, what you need to do, average is equals to sum of observations by number of observations. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 observations. Now let's do their sum. 6, 13, 21, 37, 39, 25, 38, 38, 132. Okay, 140. It is 144. So 144 by 9 will give you, okay, 16. So this was the basic way. Now if you keep on doing like this, because I am reasonably good at addition and all, I am able to do in hardly 40 seconds. Some of you may take much more time, particularly those people who are weak in calculations. First, the disadvantage is they will take much more time, and two, you are prone to errors, right? You are prone to errors. Instead of 25 plus 18, 25 plus 28 getting you to 53, you may take it as 43 or 48, or some of the other mix up will happen, particularly in those moments of exam stress. A better way is what we call a deviation method. And like in all the topics we have previously seen, since you are my students, you should be different from what others do. You should always follow the deviation method, and I will tell you why it is that simple too. So what the deviation method tells us is that instead of looking at sum of the observations, take any observation as its average, assume any observation as an average. And so let's take this here: 2, 4, 7, 8, 16, 24, 25, 28, 30. Assume any number. We know that average lies between extremes, so 2 and 30, any number. Okay, for my sake I am taking 2 and 30. Okay, 15. I am taking 15 as an average. My deviation method tells that the deviation at average is always equals to 0. Now let us see the deviations at 15, because I have just taken a random number and taken it as 15. Now, the deviation here is minus 13, and here it is minus 11, and here it is minus 8, here it is minus 7, and here it is plus 1, and here it is plus 9, and here it is plus 10, and here it is 15 plus 13, and here it is 15 minus 30 plus 15. Okay, these are the deviations. Hardly each second for each, because these are all small numbers, we will be able to do faster. Now, what does it tells? It tells that deviation at average is equal to 0. If my 15 is the real average, it should be 0 here. But is it? Now, cancel all the deviations that you can. Now, what do you see here? You look, see, plus 15 is cancelled by minus 7 and minus 8. Okay, plus 10 and plus 1 is getting cancelled by minus 13, and plus 13 is getting cancelled by minus 13. So, the net deviation is plus 9. But what does the law say? At your average, the deviation is 0, but we have a deviation of plus 9. So, the real average is equals to deviation by number of observations. The change you need to get to the real average is deviation by number of observations, which is 9 by 9, which is plus 1. So, my real average is 15 plus 1, which is 16. See how simple this is. The advantage 1 in doing this method is, first, cancellations. So, since there are many calculations, you can even see and cancel. So, it is visual and much more faster. So, the method is much more faster and then less prone to mistakes. Because instead of adding 24 plus 25, we are adding 24 and 25. Since we are going to larger numbers, many of us are not uncomfortable, but we are always remaining here in the range. See, even though there is 30, we are considering the substantial part that we consider for result is plus 15 only. It is always deviations, minus, something is getting subtracted. So, always the numbers are small and things are much more cleaner and faster and less prone to damage, less prone to errors. So, being my students, from now onwards, you should always consider deviation method. Now, let us see how we can solve. Now, this is an this is an UPSC CSAT question. Now, if you would have gone the other way, the way to do this was, okay, a student appeared in 6 papers, good. The maximum marks are same for each paper, okay. His marks in these papers are in the proportion of 5:6:7:8:9:10. Overall, he scored 60%. How many number of papers did he score less than 60%? That is what he is asking. So, now, in conventional way, like how others do, first what we need to do, we need to find out what this 60%. So, 6 papers, I am assuming that my maximum marks are 100 in each paper. This is the conventional way or the way others do. So, maximum marks are 100. So, my total marks will be, in 6 papers, it will be 600. Since he has achieved 60%, so it will be 60% of 600, it will be 360. Now, what does this 360 reflect on? All the marks is scored. This is just a ratio that is given. So, since it is ratio 5x plus 6x plus 7x plus 8x plus 9x plus 10x is equals to 360. If you do the calculation, 11, 18, 26, 36 plus 9, 45x. So, x is equals to 360 by 45. That means x is equals to 80. So, the marks he obtained are 5 into 8, 40, 6 into 8, 48, 7 into 8, 56, 8 into 8, 64, and 9 into 8, 72, and 10 into 8, 80. Now, he has asked, he has scored less than 60. 60 is, the maximum marks are 100, 60% are 60 marks. So, this is 60. So, in 3 subjects. So, 3 is the answer. So, this is what you need to do for the basic method. But now, let us see our one way. We are given 5 is to 6 is to 7 is to 8 is to 9 is to 10. Let us see. You will be amazed how deviation method simplifies this problem. This is, the reference here is student. Okay. Now, here those are maximum marks. Okay. So, when compared to maximum marks, his average, I am denoting by this line, his average, which is 60%. This is 0%, this is 100%. Now, you have seen this, right? What does this tell you? It means there is only one step deviation here. Okay. Now, if you observe our deviation method, since this is, you take any value in between here. Since the deviation is only 1 between all, the upper and lower one will get cancelled, and your average will be somewhere between 7 and 8. Why? Because my deviation method tells us positive and negative deviations are 0 at my average. So, for the deviations to be 0, the average or the real average has to be somewhere in middle of these two. So that because it is in middle of these two, then only the deviations will be 0. Now, this is his 60%. In how many subjects did he score less? 1, 2, 3. 3. It is that easy. It is that easy if you follow the deviation method and understand it. So, see, here you need to do this much thing, but by following deviation method, it is just a visual problem. You need not go for calculations, anything and all. It is that simple. So, from now on, if you get any question where they ask you average and they give you various samples, don't go by this. This is outdated. People who have learned it, they are stuck there. Update yourself and like in all the topics we have seen some or the other way to change the approach is different. So from now onwards always follow the deviation method. Like you see in percentages we have seen our approach was fractions. In ratio and proportion our approach was differences. So in every topic we have dealt with a new way of doing it, and even here from now on averages is not equals to, you don't see average as sum of observations, you see it as deviations. Change your approach and it will be, all your problems will be solved much more faster. So let's solve next questions.